Hi, we are the Race Control and Testing team. Our project was to help the director of the Triton AI Lab, Dr. Jack Silverman, with the development of a human-machine interface for an autonomous race car.
Hi, my name is Alexis. I am a first-year computer science master's student.
Hi, my name is William, and I'm also a first-year computer science master's student.
And now presenting The Race of the Geeks, autonomous race car and two student geniuses, starring Alexis as Genius 1 and William as Genius 2.
Are you tired of not being able to easily control your multi-million-dollar autonomous race car? Do you wish there was some simple way of interacting with it?
Yes, but my car is in Hawaii. How will you achieve that?
Not to worry, Jack. We are student geniuses after all, and we have just the solution for you.
Introducing our autonomous race car interface. With this modern HMI, you'll be able to control and monitor your vehicle with ease. That sounds great. How did you make it?
I'm so glad you asked. Well, we first started off defining some requirements for the HMI.
We wanted our HMI to display crucial data coming from the race car, including speed, rotations per minute, and fuel level.
We also wanted the HMI to be able to send commands to the race car, including setting the car mode, for example, attack or defend, setting current status flags, and setting various maximum speeds under different situations.
After we defined the requirements, we then drew up a quick design of what we wanted the HMI to look like. We decided to build the HMI as a web application so that it can be accessed on a wide range of devices. However, before we jump right into it, we first did some research on what tools would be the best for the job.
We considered many different front-end frameworks that could be used and eventually settled on Svelte. Svelte is a modern framework for building performant web applications, which is well suited for our purposes of building an HMI that would have to process and render data in real time.
With our tools decided, we got to work. We first built a prototype HMI based on the initial design we came up with earlier. After building this prototype and showing it to the Triton AI team, we received some feedback on how to improve. Based on this feedback, we came up with a new design for the HMI, which would be more user-friendly.
Using this final design, we built version 1.0 of the HMI. With a working front end, it was now time to focus on the back end and connect the HMI to the race car. We started off using simulated data contained in CSV files, communicated using the robot operating system known as ROS. Our HMI reads these CSV files to display information such as speed and RPM in real time.
Once our HMI was working with simulated data, we wanted to test the HMI, so we went to the Triton AI lab. However, the vehicle did not have sensors for the information we required, and this became somewhat of a setback for us.
Nevertheless, in the end, we created a well-documented API that would allow future team members to easily connect any sort of data to our HMI. With this, we achieved all of our goals and were able to come up with a satisfactory solution for the Triton AI team.
Can you show me?
Of course. Welcome to our HMI. So there are 5 main components of the interface. The info bar at the top displays the current car number and the day and time. The gauges in the center displays data coming from the race car. The controls on the left allow selection of which car to connect to and setting the car mode. The flags on the right allow setting current status flags, and the speeds at the bottom allow setting various maximum speeds. For the flags, you can select whichever status flag is currently being raised, like so. For the other values, controls, and speeds components, you have to set the value explicitly with a set button, which are the circular buttons. You simply select which value you want to set and then push the set button to set it. So, for example, if I wanted to set the attack mode, I would simply select attack and then click on select mode to set my decision. And the other set buttons work in the same way. While the set button is active, the currently selected value cannot change. To simulate connecting to a race car, select any car number and push select car. This will fluctuate the gauge around a set value to simulate the car racing. If the car number is selected, the gauges will race from one end all the way to the other, as shown here. What do you think, Jack?
Well, guys, that was amazing. This is exactly what I needed. It would be a crime for both of you not to receive an A in the class. We agree,
We
Jack.
agree, Jack.
Can we get those tickets to Hawaii you promised, by the way?